Welcome to the Polar Steam Cool Connections live stream. While we're waiting for folks to join, please post where you're watching from and how many people are watching from your location. We're really excited to have you all here today. I'm Melissa Barker, the Polar Steam Program Director, and we'll just give folks maybe 30 more seconds to get onto the live stream and get situated. Welcome to our classes. Welcome to the classes that are joining us today. We're really excited to have you here. So again, if you're just joining us, please go ahead and post where you're watching from and how many people are watching from your location in the live stream. We're excited to have you here live in Antarctica today with the COLDEX team. We'll be starting momentarily. All right, welcome everybody. We're excited to have you here for the COLDEX live stream, live from Antarctica. I'm going to just introduce myself again, Melissa Barker. I'm the Program Director for Polar Steam, which is a U.S. National Science Foundation funded program based at Oregon State University that facilitates virtual and field-based collaborations between polar researchers, educators, and artists to enhance science communication, bringing polar science to everyone. A recording of this live stream will be posted on our YouTube channel. While we don't have an educator or artist out in Antarctica with the COLDEX team today, we've had a few virtual collaborations between educators and COLDEX researchers in our program. And the middle picture here is one of our educators working with her collaborator at the NSF Ice Core Lab, doing some work on ice cores, which we're really excited to hear more about today. Today, we're connecting with the COLDEX team on the ice in Antarctica. We will start the presentation from the COLDEX team. They're again at Allen Hills, and they'll tell us all about that. If you have questions, please put those in the chat. Our team will monitor those questions and then we'll address them after we've had a presentation about what the team is doing out on the ice. And with that, I'll go ahead and turn it over to the team from COLDEX, and they'll introduce themselves. So Martin, turning it over to you.
Hi, from Antarctica, Allen Hills. We're here in Antarctica at our field site at the Allen Hills. It's a cold, sunny, windy day today, as it typically is out here. I'm Martin Fragisilva. I'm the NSF COLDEX digital content coordinator, and I'm out here in the field as an ice core handler.
Hello, my name is Ann Lee. I am a PhD student at the University of Washington in Seattle, and I'm out here as the geophysics lead with the COLDEX field season this year.
I'm Danielle Whitaker. I am the managing director of NSF COLDEX, and I am here as an ice core handler as well.
Hi, I'm Romilly. I'm also a core handler for the NSF COLDEX team, and I'm co-science lead as well for the second half of this field season.
And so we've been in the field out here in the Allen Hills for nearly 7 weeks now. The main purposes of our being here have been to collect old ice cores, some of the oldest ice cores ever collected in the world, as well as do a series of geophysical measurements of the area to better understand the area that we're in, to better understand how the ice is moving and flowing, and where our team could find old ice. There's about, I think there's 12 people. We've had 12 people on average in camp. We've had some people come in, some people come out. We each have, almost all of us have our own tents. Some people share tents to sleep in. We have 3 hangout tents. So we have a storage tent that we're in right now. We have a lot of equipment in here. We charge our batteries here. We have meetings in here. We have a hangout tent where we eat. We have meetings. We generally rest in. People read books in. It's kind of the place to go to after a long day of work. And then our third communal tent is our cook tent. So we have a whole kitchen in there with propane stoves and a bunch of cooking utensils and ingredients. And we have 2 dedicated staff who mostly do all the cooking for us, and they cook every day for dinner. And so we have hot food every night, which, given that we're in the middle of nowhere, hundreds of miles away from any heated, hard-sided building, is pretty impressive. I think I'll give an overview of kind of like what a basic life here is like, and then we'll jump into ice core drilling. But essentially, our days here have been split between ice core drilling and doing geophysics. We've had multiple sites where we've done ice core drilling, and Romilly can talk about that now.
Okay, sorry. So if we go to the next slide, please. Okay, so yes, this is just an overview of our 3 tents, and the third one, as you can see, is not a real tent. It's called windscreen, so we can block all the very strong winds that we constantly feel at this site. So I'll just talk you through the 3 kind of drilling techniques we've been using. The blue ice drill, or the BID, and this drill gives us 9.5-inch diameter ice cores. And this is really useful for us, so we can get measurements of all different types of things on this ice. And this one we finished, well, quite a few weeks ago now, and we drilled to 91 meters. And then we did a second core actually to 25 meters with this drill. Then in the middle, we have the shallow wet drill set up. And this one we drilled to 327 meters. And this uses a slightly different technique. It's a smaller diameter, about 4 inches. And we use fluid in this, so that's hence the shallow wet drill. And by adding fluid into this borehole, effectively, we can improve the quality of our ice cores. So normally, when you get that deep without fluid, they are broken up, and it's very hard to log and analyze these cores. So instead, we use fluid, which helps with that core quality. And then in the third picture, this is our hand augering setup. And as the name suggests, we effectively do it manually. Semi-manually drill for ice. We have done 4 hand auger cores this season, down to a total of 80 meters, more or less. And this is Martin here, doing the hand augering behind our very nice windscreen. And this is even smaller cores, 3-inch diameter. And we can kind of do these wherever we're interested in the ice, wherever we think the ice may be a bit different or old, or, we use this as a kind of recce to figure out where would be best to drill in future as well. Would you like to add anything?
I think, the shallow wet drill is interesting, and we call it the shallow wet drill because it's wet. We use fluid. We use a sort of drill fluid to do it. The drill fluid does multiple things, but notably it helps maintain the integrity of the cores the deeper we go, because the deeper we go, the more pressure there is in the borehole. The borehole basically, because of the depth and the pressure of all the ice, wants to collapse in on itself. And so we use the drill fluid to prevent the walls of the hole from kind of closing in and destroying the cores that we're collecting. That's one of the things it does. The other thing it does is it lubricates the drill system, and it keeps the cores intact as we lift them up up onto the surface. And for the first basically half of our time, we were able to drill without using the drill fluid because we weren't going too deep. And then as soon as we hit a certain depth, can't remember exactly what it was, 115 meters, we switched to the drill fluid, which changes the whole dynamic. One fun fact is that we also started doing double shifts for the shallow wet drill. So while for the blue ice drill and the first half of the season for the shallow wet drill, we were doing a typical, 9 to 5, 9 to 5:30 day drilling, essentially nonstop. For the shallow wet drill, towards the second half of our time using it, we switched to 2 shifts, a day shift and a night shift. So the day shift drilled from 8:30 to 5-ish, 5:30, and then the night shift drilled from 7:30 to sometimes 2 or 3 a.m.
Yeah.
And Danielle and Anne were both on the night shift. And night shift is, a funny thing to call it here because the sun never sets in the summer. So you step out at 3 a.m. and it's still as sunny as it would have been at 3 p.m., which is kind of trippy. But also, it does make working here easier because we can see everything all the time. Yeah.
One thing I would add, and this is good place to slide to show. It might be confusing that we're calling it the shallow wet drill when it is actually the deepest core that we drilled. So it might be a good time to explain why we're specifically in the Allen Hills. This is what's known as a blue ice area. It's called that because the ice looks blue from the surface. And basically this is a special area where ice that was at the bottom of the ice sheet or the glacier has been pushed up to the surface. So unlike some of the traditional deep drilling projects where they will drill like kilometers into the ice to get a continuous record of how things went over time, we actually have ancient ice at the surface, so we don't have to drill very deep. So we're using the same techniques here with the shallow wet drill that they would use to drill, a 2-kilometer ice core, but we're only going, just over 300 meters.
About 1,000 feet.
Yeah.
Yeah. Yeah. As opposed to thousands of feet.
As opposed to
Yeah.
thousands of feet. Yeah, so this is a view of the inside of the tent. So once the drill pulls up cores a meter at a time, we put them on this is the processing table, and the core handlers then take measurements and take some notes on these cores and then package them up to be shipped back to the United States, which will take a few months for analysis. And maybe, Romilly, do you want to talk about what we're interested in these cores?
Yeah, excuse me, sorry. There's many different measurements we can do. One of the main measurements is the argon isotopes in the air bubbles that are trapped within this ice core. And this gives us a date. So we need to basically date the cores. That's the fundamental part. And that's how we've got these dates of 3 to 6 million year old ice that we've found in this area. So there's loads of different measurements we can do on the air that's trapped within the bubbles within these ice cores. There's measurements on these. We see some sediment layers or some dust layers in the ice cores, and people study the composition of this dust or sediment to understand various things about the ice sheet history or the climate history. What else do we measure? The ice itself, which gives us a kind of temperature record going back up to 6 million years. Yes, and also just all the major gases of the air, or the greenhouse gases. So getting a CO2 record back over this whole time period that we're looking at is one of the most important things that COLDEX has been doing. And the recent papers recent papers have been published on this. And the greenhouse gas record is one of the fundamental things that we have got out of this ice. Yeah.
I can talk a little bit about the geophysics that we've been doing out here. So generally the different techniques that we're using are all aimed at understanding the subsurface. So below what we can see on the surface, we're interested in the ice dynamics and what is going on that we can't see with our eyes alone. And so here are 3 examples of the instruments that we're using this season. So the first one I'll talk about is APRES, which stands for Autonomous Phase Sensitive Radio Echo Sounder. So this is an instrument that basically it has 2 antennas, and you'll see on the left-hand side where there are flags, the closest flag and then the furthest flag, there are 2 like white metal frames. And so those are the antennas. And so there's a transmitter and a receiver, and one antenna sends the signal, the other one receives it. And in that way, we can essentially measure how fast the ice is being strained. So like, you know, within the ice, there's like different layers, and we're interested in how fast it's being compressed versus pulled apart. And it's kind of like a vertical velocity in a way. And then GPS, or Global Positioning System, this is something that you all are probably familiar with. You know, we have it on our phones like Google Maps, but this is a very precise version of that. So for the GPS, we have, like the APRES, multiple sites all across the ice sheet. And by taking repeat measurements every year of the precise location, we can then compare between different years to see how fast the ice is flowing horizontally. And then on the right-hand side, there's an example of the ground-penetrating radar setup. So this is an instrument that we have to actually pull along the ice and walk with it. And so for this instrument, it's also sending radio waves. So within that one orange box that you see, there's both a transmitter and a receiver. And with that, we can then image the subsurface and get an idea of different layers in the ice, you know, whether there are debris bands or like different types of sediment within the ice. We can get an idea of how thick the ice is, so like how deep until we hit bedrock. And by kind of like doing a whole grid across an area, you get to constrain, like, okay, in this area, this is how thick it is. We can kind of get a better picture of how the ice is flowing and what it's doing in that area.
I think the coolest thing for me from the GPR setup has been just this, thinking of this idea of like, it's sending waves down to the bedrock, and those waves bounce off of the ground under the ice back up, and you get like almost a live feed of what we're standing on, which is so cool, you know. Yeah.
I'm going to pop in just with a question specific to this. So are you using then these measurements to figure out where to drill, or had you already decided your locations?
So kind of a combo of both. So this year we kind of came in having a general idea of where we wanted to drill based on prior year drill sites, and also based on prior year, for example, like ground penetrating radar measurements. The measurements that I took this year, they could be used for helping with determining future drill sites as well, though that wasn't necessarily the goal of these measurements this year. Yeah, so it's like we usually, when we select drill sites, and Ron can talk about this more too, it's like we use both like what we've seen from previous ice cores and what we know what the ice looks like in that area, along with like the first kind of step is like, yes, using the ground penetrating radar to figure out the ice thicknesses, and yeah, that's the measurement. So.
No, exactly. And just to reiterate that, so with the GPR, we can sometimes see internal layering, and we can see how the ice, in an area, how the ice kind of behaves more or less. So if we've drilled a core before and found really old ice somewhere, so for example, this year we went back to a similar area, used the GPR to check that we were in the right, in the similar behaving ice as the previous core, so that we are sure we're going to get the old ice in our core that we drilled this year. So we kind of, they both complement each other, the ice core and the GPR, and we kind of go back and forth.
Yeah.
Okay, that's helpful. That helps me put together the piece about like the folding ice, and then you being able to figure out by using the radar. I was thinking, like, how do you know how old that ice is, right? When you're drilling somewhere where the ice is folded. But it sounds like using these different tools together is helping you to do that.
this and another technique that's back in the lab called oh gosh, ECM. No, the
Oh,
Electrical magnetic.
no,
No, wait.
electrical continuous measurement.
measurements. Yes.
Yeah. Yeah.
Yes. Sorry. This is what we use.
Conductivity. There we go.
There
we go.
conductivity
We got
measurements.
Yeah.
Which is basically is showing that's a really useful tool to see the folds. So when we have these measurements on an ice core, and then we drill close by as well, it's basically all of these things together that we need to be able to choose our drill site, and that's exactly what we did this year for the shallow wet drill. So we're hopeful that we know more or less what we're getting based on these different techniques.
Perfect, thanks. All right, next slide. Good, yeah, okay.
Yeah. So
Go ahead.
no. If you want to talk.
You can-
Yeah. No, I mean, I'll just say that, life at camp life in Antarctica is very different than life back home. We don't have running water. We have limited heated spaces. We all sleep in tents every night. So we're all now expert winter, and I say winter because it's technically summer here. But it feels like winter outside. Winter campers, and we have really windy days. Sometimes we've had up to 40 plus knot wind days, which is about 45, 50 miles an hour winds. And these winds will often bring snow in from the interior of the continent. So upwind is all the snow that's sitting on these glaciers, and the winds will come in and blow off the surface snow. And because we're in the way, we get a lot of that surface snow, which can bury our tents under snow. So we have to, well, not all our tents, but like the edges of the tents. And we have to dig out our tents very frequently, especially when there's a lot of snow. We have to dig out the entrances of the tents very frequently so we can get in and out safely. The snow gets everywhere. So everywhere. If we leave our pockets open and we walk outside, we will walk into a tent and put our hands in our pockets, and there's snow in the pockets. So that's a real thing, which I did not expect before coming here, and it has been. So now I have to really check all my pockets; they're closed before I go outside. Otherwise, my jackets will get soaked from within. But we also have one of the most beautiful offices to work in. This is the photo on the left is a view from our drill site, so you can step out the tent and see this. And that's on a beautiful sunny day. We've had some beautiful cloudy days too, but mostly it's been very sunny and windy and cold. But it's life at camp. So this is our little home for 7 weeks. Yeah, I know. Anything else to add?
It's a good summary.
Yeah. Next slide. Yeah, here's some other highlights. The photo on the left is a mountain called Mount Brooke. It's actually past the Allen Hills, but it's so big that it looks like it's really close. And we see it every day from camp. And we know it's cloudy and foggy if we can't see it, which happens frequently enough that it's noticeable. The central photo is, oh yes, a Nunatak.
It's the Nunatak, and just next to this Nunatak is actually where the 6 million year old ice was drilled in previous seasons. So yeah, this is the Nunatak. That's basically is a little bit of mountain top that's sticking out of the ice, and here is, well, on the left side of this is where the ice core was drilled with the 6 million year old ice. So it's a good one.
And then the last photo.
Yeah, so we're here in the middle of nowhere, but we're not actually cut off completely from the rest of the world. We get flights that come in here regularly. So this is a Twin Otter plane They come in to bring us food resupply. They pick up our ice cores and take them back to McMurdo Station. We're actually only about an hour's flight away from McMurdo. And so if anything happens, they could get us out of here quickly if we ever needed that. So we're pretty well connected to the rest of the infrastructure here in Antarctica. Do you want to talk more about the flights? Because they actually are about to make up a big part of our day. The rest of today, if all goes well, if the weather holds, we're expecting 4 flights today to take away all of our cargo for the drilling equipment. It's actually 10,000 pounds of drilling equipment that's here. It's all packed up and ready to go because we're finished drilling. And that's going to take 2 flights to get that out of here. And then we're going to have another plane take away some ice cores. And then the 4th one is actually going to be taking away some of our personnel who are finished here.
Yeah, I guess I can confirm that the flights are there for us if we need them to bring us back to McMurdo. I was emergency evacuated last week because I lost a tooth on the blue ice. And luckily they were able to get me out, like not the next day because of the weather, but the day after. And then I was able to get a root canal in McMurdo and then come back the day after back to camp. So yeah, it's and yeah,
With pizza.
Yeah.
Yes, you got us pizza.
yeah.
We are extremely lucky to have amazing teams of people back home and especially in McMurdo who are there to help us and support us and make all this science happen. And the pilots and the medical staff and the cargo, people and the science people at the science lab in McMurdo, like make sure that everything, gets taken care of, that our ice cores stay cold, that they arrive safely. It's pretty amazing when you think about like the entire infrastructure that enables this to happen for science. Yeah.
All right, I'm gonna stop sharing the slides there. Awesome. That was super cool. Thank you so much for kind of talking us through what you're doing and what it's like living there. I'm sure we're gonna have lots of questions about that. So let's see, I'll just start. We've got a whole bunch of questions for you all. Let's see. So first of all, there's a lot of talk about the oldest ice and like what makes the oldest ice in Antarctica so valuable for understanding climate history. Like, why are you guys spending all this energy out here getting the oldest ice?
Well, so one of the big things is that ice cores provide one of the only direct records of past atmospheric composition. Because of how the ice cores form, they trap air within bubbles in the ice. And unlike other archives where you kind of have a proxy record or something that represents, you have to basically calculate back to get your atmospheric composition. The ice cores literally store a little snapshot exactly of their past atmospheric composition within them. So when we have ice, before COLDEX, the oldest, the oldest clean ice was 800,000 years. This is a big record and it's continuous over 800,000 years. But these new records allow us to extend our atmospheric composition records back way, way further than this, and tells us lots about the Earth's climate back before, 3 million years, where the system was very different. It was much warmer in our Earth system. So it's really useful information, especially given the warming that's happening at the moment. So we can understand better how the climate responds to changes in atmospheric composition and the feedbacks between this. I don't know if that answers the question, but yes, it's basically a really fundamental, all these really fundamental questions about Earth's atmosphere in warmer climates and how it works. Anyone wants to add anything?
I think so, just jumping.
Yep.
going off of what you said, I think like the important distinction to make is that we are not collecting continuous ice core records. We're collecting discontinuous ice core records, which is one of the main reasons why we're able to collect the oldest ice ever collected in the world, because we're not going from 0 to 5 million years ago. We're going from something to 3 million to 6 million. The continuous ice core records are their own very valid, very important records, but it's not what we're doing here at NSF COLDEX.
Thanks. That's helpful clarification too, because I think I picture personally like a long ice core, but you guys, it's like sections, and so that's great. I think we maybe wanted to just like peek outside.
Yeah.
Do you want to take us outside and just show folks like what is it actually like outside this beautiful cozy tent?
Yeah, let me do that quickly.
Okay. Yeah,
So
we won't stay long.
I will kind of dress up a bit because it's windy and I actually need my sunglasses because it's very bright out there. And if you don't wear sunglasses for, a while, you might get snow blindness, which basically burns your retinas. So safety first.
Safety first.
Okay, so this is kind of the exit to this tent that we're in. So I'm gonna open the zippers and you'll kind of get a sense of what it might get windy, so you might not hear me, but here we go. Okay, so I don't know if you can see much. This is basically what our camp looks like. That's our hangout tent, and behind that is our cook tent. You can see Mount Cook in the distance. And you can see it's pretty windy today and snowy, so we're getting a lot of that flowing snow. 1 second. Sorry, this is slightly awkward, but I'm trying to remove the background. My mouse is not working. Sorry. Trying to unblur background. All right, that should be better. There you go. All right. So yeah, you can see in the west, that's our hangout tent, that's our cook tent. And in the background is these are our snowmobiles that are covered so they don't get all snowed in. Over there in the distance is our cargo line. That's where a lot of our cargo is being placed for the flights. Yeah, so my laptop is now freezing, so I'm going to go back inside. But this is basically our camp. Okay, they're also freezing, so here we go.
Awesome. Thank you so much, Martin, for taking us outside.
Yeah.
We actually
I hope
didn't
that worked.
hear. Yeah, no, it totally worked. Didn't hear that much wind sound, but you could see it. So
Okay,
that was really cool.
That's good. The noise cancellation works.
Yeah, yeah. Awesome.
All
That's really cool. Gives us a little taste of kind of what you're dealing with on the day to day. So let's see. Well, I think this is kind of an appropriate one. People are wondering how you stay warm at night. I mean, we just saw outside and it looks pretty darn cold. Like, how do you guys keep warm? How do you, you're sleeping in tents? Tell us about this.
So we're actually provided with a really effective sleep kit. So you get a couple layers of foam padding, you get a thermarest pad, and then you get these like massive sleeping bags that are rated for 60 degrees below zero. They actually keep you really toasty warm. And often in the middle of the night, I will wake up being too hot. And I'll like unzip it a little, put like my arm out or a foot out to get that cooled down and then go back to sleep. So yeah, it can take a few minutes to warm up when you first go to bed. So on a really cold nights, you can fill up like a water bottle with boiling hot water and put that inside your sleeping bag to help get the process started. But actually, like we sleep pretty warm at night.
Yeah, we also have two different types of tents, and the little mountain tents I think are a lot warmer. And I don't know if you just saw the Scott tents, the big triangular, yeah, yellow ones. They're a little bigger. We share them with two people, and they're also a little bit colder than the mountain tents. So yeah, it's good.
Nice. That's pretty amazing that you get hot at night.
Yeah.
Especially on low wind days.
Yeah.
Yeah. Okay, so let's see. So someone had written in a question about drilling cores in glaciers and seeing worms and larvae in Alaska, and they're wondering, does Antarctica ice harbor such a habitat, and why or why not?
So, I can start, and then please feel free to jump in because I don't. It's not my area at all. But it's less. Yeah, it's less likely to find such living things in Antarctic ice at depth. I think I don't know if there has. We see some fossils in some areas, but to my knowledge, there's nothing that's really been found living, or not living, or apart from microbes.
I guess. Yeah. The only other example, like Lake Vostok, which you
Lake
probably
Vostok.
know more about. Yeah.
I don't know much about Lake Vostok either, but at the bottom of Vostok, an ice core in central East Antarctica, there is a massive lake that they accidentally nearly drilled into. And I think there are things living, but it's very different to what we are used to elsewhere in the world, if as I understand it. Yeah.
Yeah, I could add, we are actually near an area that has fossils. We visited on a little field trip one day. There's a lot of petrified wood, and there's a former forest that was here, but that dates back to 250 million years ago. So like that's a whole two more orders of magnitude older than what we're looking at. So the time periods that are captured in the ice, I think Antarctica has been very cold for a very long time. Point.
Awesome, thank you. Someone's asking about sort of the cycle that I guess in the film Antarctic Ice and Sky, there's 100,000-year cycle, and again in that Vostok ice core showing about 80,000 years of ice age, and then 20,000 years of more temperate. So I'm wondering if you can discuss sort of the current thinking on this, and if you, like, is your work helping us shed light on this at all?
So I'll just start with this one as well. These 100,000-year cycles have been persistent over the last 800,000 years, more or less. And typically what we are in the Allen Hills, what we get is older than this. And if it is younger than 800,000 years, the resolution of the ice is not kind of high enough. We don't have enough. We don't have enough ice resolution, if that makes any sense, to look at these cycles in this ice. And this, yeah, I'm not explaining this particularly well, but yeah, we don't typically look at these cycles in the Allen Hills ice. We're more looking at long-term averages, going back to several million years. And there's many reasons for that. The young ice is typically ablated or lost at the surface, which is why we get the old ice. And so this time period, we don't look at so much. But yes, these 100,000-year cycles are very clear in other bicycle records that are continuous, but less clear in our discontinuous bicycle records. If anyone wants to add anything as well.
I could add a little bit to that, and maybe you could correct me if I say anything wrong. So Bob mentioned that those cycles have held for close to 1 million years. What she didn't mention is that before that time, the cycles were a different length. They were 40,000 year cycles instead of 100,000 year cycles. And we don't understand why they changed, why those climate cycles changed. And so that's one of the reasons why ice core scientists became interested in finding ice older than 1 million years, because that would give us a window into that period of time where the climate cycles were different. And so we are in a period of change right now. We don't know what the future holds. So looking at what happened when the climate was really different than those cycles can help us predict what could happen next.
Awesome. I want to just give a quick shout out to some of the schools, especially some of our middle schools who are watching. We've got Chisholm Middle School and Sky School who are watching, and we have some questions that, and Team Spartan, some questions from them kind of again about camp life. And some of them are wondering, how do you keep your drinking water from freezing? Because it's so cold.
Yeah.
You want to talk about water?
Yeah, I can. Well, okay. How do we keep our drinking water from freezing? We really try really hard, and it still freezes. But a lot of people start with hot water in their bottles, which takes longer to freeze because it's hot. A lot of people have insulated like mugs that we hold a lot of water in, and also insulated sleeves for their water bottles. That sometimes helps. Sometimes people will put hand warmers in those sleeves, and then put the water bottle in there, and the hand warmers will create enough heat to prevent it from freezing. Some people keep their water bottles in their jackets. I keep my water bottle close to me, so it freezes, but it freezes less quickly than it would otherwise. Yeah, water will freeze if our water freezes in our water bottles. We have these stoves in our heated tents that we will just place the water bottle next to, and we just wait. Water is interesting.
We have a big pot on
Yeah,
stove.
yeah. We water here is interesting because there's no running water, so we have to collect water from the that we're in. So we have a well that's and I say well because it's not really a typical well, but it's just a patch of snow upwind from our camp, where we have to shovel snow, put it in a bucket, bring it back to a hot tent that has a big stove pot over a stove, and melt the snow, and that's our drinking water.
Gotcha. So you're drinking the snow.
And it's been
Awesome.
tested. It's very clean.
Nice. Let's see. So obviously water is a challenge, right? Like you're needing to think about it. We don't have to do that when we're not out on the ice as much. What have been some of the other challenges of daily life in camp?
I think at the beginning, using the bathroom was definitely a learning curve. Because when we pee, we have to pee into like a water bottle, like a Nalgene sized 1 liter bottle, and then we dump that into a bigger drum that holds all of our pee. And so, yeah.
And what do you do with the big drum?
It gets shipped back to McMurdo and processed with the wastewater there. Yeah, so that's definitely took some getting used to. But one thing that's important is you can't leave any human waste here. So all of our waste is packaged up and taken out of here on airplanes.
Wow, that's pretty amazing. What about any penguin or wildlife sightings?
Yeah, go ahead.
Well, okay, so penguins and seals and other wildlife in Antarctica are heavily dependent on the ocean. And so you usually only see them on the coast, and we're pretty far inland. We have seen 3 birds in our 7 weeks here that have flown over camp. It was a very exciting experience. We've seen a South Polar skua, which is a kind of predatory bird, and we have seen a snow petrel. They kind of wander in looking for food, maybe get blown in on the winds. But they don't stay for long though, because there's nothing for them to eat here. And there are no penguins in this area, sadly. Yeah.
But when we take our flight back to McMurdo Station, it's closer to the sea ice there, or just to the water. And so When I was just back there last week, I did see penguins when I was medically evacuated there. Yeah,
So that was cool.
probably yeah. That's a perk of being medically evacuated. Yeah, yeah,
Nice.
chance to see them again when we go back.
So you mentioned you guys are taking all your equipment out and you're flying the ice cores out. How do you keep the ice cores? How do you make sure they don't melt between here and well, actually, where did they go?
So from here we store them in this trench, which is slightly below the surface. So basically insulated from the warmth of the sun, so it stays colder. And then when the flight comes in, we have to, well, we'll be doing this later today, make sure when the flight's left McMurdo, we all go down, we bring out 12 boxes per flight, and they are left on the surface only for a short period of time. Then they go into the plane, which we make sure that the pilots don't turn on the heating. They have to stay in the cold. And I'm sure that's very annoying for the pilots, but they do it and it's great. Then they arrive in McMurdo, and there's a whole cold chain. There's a whole, it's a very big movement. Basically, we have the cargo team who pick it up, make sure that it's staying cold all the way to this freezer facility at McMurdo, where they will stay until they are put onto a reefer, which is basically a freezer in a what do you call it? Shipping container, exactly. And they go in this all the way back to the US, and then get driven from the coast they get on a boat to the US, driven from the coast to Denver, where they go to the icicle facility, which, they stay very cold there, minus 35 Celsius. I don't know what that is in Fahrenheit.
Pretty cool. Yeah. One other thing I'll add is that the boxes that we use to store the ice cores are these heavy-duty insulated styrofoam with mylar reflective material boxes, and we store the ice cores in these bags that keep them clean and organized, and then we fill those boxes with more snow. So the boxes stay very, very cold, and that helps insulate the cores as well throughout their whole journey.
Well, that's a lot of travel for the ice cores. That's great. So let's see, thinking about, we have a lot of students who are watching, so maybe Anne, maybe you could tell us a little bit about like your path, like where you are today, just kind of briefly, like how did you get to do what you're doing right now?
Yeah. So I grew up in Colorado, kind of like at the foothills of the Rocky Mountains. And I think for me, like nature is a big part of my life in terms of like hiking and snowboarding. And I was kind of like looking for ways to like, how do I incorporate this more into like my future work? So in college, like I started out studying more like things that were like further away. So I majored in astrophysics, and then it actually wasn't until the end of my college career that I added on geosciences as well. And so it was kind of like towards the end of my college time that I was doing like more earth sciences focused internships, and just like was really fortunate in the sense that I got to explore a lot of different areas, and then also got to take a class that was more oriented towards like earth sciences. And I was like, okay, this is actually more of what I want to be focused on, rather than astrophysics is very cool, but it's like much further away. I can't go into the field and like hold what I'm studying, or like, be as tangible with what I'm looking at. And then so during my last year of college, I decided to apply for grad schools and go through that whole process. So I applied for PhD programs, which in the US for science fields, you can actually get, like, when you get those positions, they're typically funded. So you get paid as a PhD student. Not very much compared to like, industry jobs, but it is enough to live on. And then so in the US, you can go straight from like college into grad school. So that's what I did. And then, throughout grad school, I was really looking forward to like being part of fieldwork because that was something that I didn't get to do as much in undergrad. And so I really sought out those experiences. So yeah, very grateful to be here in Antarctica with COLDEX. And yeah, I think honestly for me, it's just like trying a lot of different things and exploring through like internships or like classes or, you know, extracurricular activities, trying to figure out like where or what things I was most curious about and most interested in learning more about. Yeah, I guess, Rob, you also recently finished your PhD.
Yeah.
Do you want to talk about your path or like?
Oh, I've just reiterated similar. Basically, if you find something that is super interesting to you and you're passionate about, just pursue it because it does. That's how I effectively got here. It's just constantly reassessing like what's interesting to me and how I can make that in my work. Yeah, incorporated into work life as well as passion side. So I have a similar story to Anne. Just finished PhD just over a year ago, and now I'm working at Oregon State University, which I forgot to mention at the beginning, as a postdoctoral scholar, which is basically a junior level researcher, let's say. So yeah, and again, I always sort out field experience as I love it out here. So I'm working with a team, a great team. Yeah.
Awesome. Well, I apologize. We're not going to get to everybody's question today. We have lots of great questions. We need to wrap it up, but I'd love to just ask Martin, you know, I know you guys are wrapping it up and moving out of the field, but if people want to follow along and like kind of keep track of what you guys are doing, how do they do that?
Oh yeah, thanks. Well, we have a website and we publish regular newsletters about our field experience. You can go to coldex.org/blog to read our blog posts and kind of get a deep dive into what our weeks here look like and what our work looks like. And we've also been sharing our experience on social media. So you can go to on Instagram, it's COLDEX, COLDEX_STC, COLDEX STC, which is a Science and Technology Center, but that's neither here nor there. Is our Instagram handle. Videos kind of explaining the work that we're doing and a closer look at that, as well as LinkedIn. So we have a LinkedIn page, which is NSF COLDEX. And yeah, those are the three main places you can find us, at least on the social media. And our website has, of course, links to our papers and more explanation about our research and how we do our work and why we do our work. So, you know, please check it out.
Awesome. Thank you guys so much. I know you have to go, so thank you so much for your time and for being here with us today, all of you. We really appreciate it. Really great learning. Thank you so much for your time. I'll just finish up with saying you've heard how to stay in contact and get in contact, learn more about COLDEX. You also can subscribe to our YouTube channel, join our email list, and follow us on social media at Polarstein Team. We like to share what's happening at COLDEX. They're friends both also based at OSU, so we really love to share what their exciting science they're doing. Remember that this recording will be available on our YouTube channel. And thank you so much, everybody, for tuning in today to Polarstein's Cool Connections with the NSF COLDEX team. Thanks so much, everybody. Bye-bye.
Thanks for having us.